Okay, this has been a pretty fun rabbit hunt so far for me. Like I said, I've had to set up a couple of things, do a couple of things. I got those things cooking right along, doing what they need to do. And I'm just playing around with some of the Amphenol numbers that I might need here in the future, kind of preparating my schizophrenia, just natural XYZ location on the planet, and manic as that can be. So I got a few things here. I generally start with the NASA 11 or 10 bullets. 90-pound bolt falling 60 feet, 100% at 600 yards, whichever methodology, H1 or H3 to HTLM, which I'm not very good with yet, but I can get this one to at least standard model a little bit for me. Come on. I can get it up here and get it to do the basic rigmarole of a basic homepage and some stuff, and then I need some help with the steps to get it to actually do stuff. But from there, generally we could talk about what the droid is, the old droidy there for a JavaScript. Hello, in the working to code, time fraud, work fraud cases, because they always give you gravity. If you have gravity, you have the right answer. It's a hard gravity to get sometimes, but welcome to Earth. Or Centaur, whatever, Alpha Centauri. You could talk about Proxima Centauri, whatever, NASA. Redshift, lensing this thing right here is a gravity wave, redshift, blue shift problem on the paperwork. Hello, yeah, how you doing today, buddy? 42? Alright, go ahead and change that over. And that's going to give you a basic play button. You come into the factory and you do some stuff later on. Like I said, we're going to be running through some information here that I might need or find relative to the company as they come up there. They're going to use their standard model. I'm going to have some basic information that should look the same. It helps you turn on the saws a lot faster, memorize steps, 15 minutes on 15 minutes, check the lights. Will I be able to improve this model if I go there and learn the housing on those things? Because that's always the shortest distance between two paths here, two lines. And again, that starts to be the rip down on a lot of this. That's going to be hello into figuring out your droid over there with just a linear layout. Well, they should have been the same thing. Well, you change a number, firstly. You've done something in the universe that's not compliant to the universe. Oh, I must have changed these all back over. All right, so, what I generally do is I'll start in samples. These are, again, standard models to their mass gap. Which categories of systems of standard models make standard values? When you demon at the gate, mark your feet, figure out the timelines. Salty one here. That's me in superposition trying to figure out my first time cracking through this thing. How do I get this to come over here and actually abide by those rules? Because the first JavaScript not gonna I'm just going to give you this, not a button, not a standard, not any of this, and especially if you don't know how to hack any of this. The first bit is to make it do anything whatsoever. Take out this, she don't work no more. And then the CNC G code don't work no more. And that's the kind of differential of two things, is sitting here for a week trying to figure out how to make this do something, and getting over here to some of these other salties. Sure. Just for demonstration purpose, I'll clean up them droids later. Getting it into the XYZ dark controls. We want to slide that over on samples from Hello World. Figure out how to put a droid on there, change this around, maybe some of the XYZ locations, the button size, because they're all parameters on the button toggle switches of control being the button, from XYZ to control in the button, to dialogues that have customs, yes and no's, alerts, and systems on lists that might compound x, y prime, z degree, or any combination of ax plus bx equals cx is going to give you some real form, depending on whether it's that or somebody likes computer engineering. So as long as you have that, you have a binary parallel Feynman diagram working this way as it shoots down the code, but runs back this way and does whatever that chip position to the breadboard here, positive, negative, negative, positive. You're going to figure out 42, starts to be a blinky light, or the combinations of the order, up or anti-up. I'm in this position, there's a range of spectrums, but is the range of spectrums marginally prepared in a direction that gives me a light bulb that works long enough, but it's fuzzily. So I know I got to fix it there. It's not just it worked, it always will work, and it fuzzles out in 2 seconds. Well, poke and hope, right? Theory of numbers, 1 0 1 0. Did it here, it worked here until all of the ones are lined up on one position where you can kind of do it, which I don't have it set up here. This is battery to wire. This is wire conductivity to as its application in a matrix and a resistance. If it hooks up to a 9-volt battery, a 1.5 volt double A battery there. And then times, space, and then battery quantum spec stuff about lithium batteries, and periodic table in here about, again, oxidation of compositions, whether it's intrinsic or utilitarian value. Really, is it 0, 1? Is it on the hot line, the cold line? Is it north? Is it south? Or just numbers people give this stuff? And those observations of this, and they have to be that. Superposition, superstring theory button here. Tom the Cat. Hi, Tom the Cat. Well, you're not Tom the Cat. Get out of here. Line tamer. Okay, get this back in here. Tom the Cat firing out marshmallows at you and the ones and zeros blinking at you. Sometimes it's a machine, sometimes it's the boss, sometimes you just gotta stay motivated, kid. Blink. Come at you, smoke coming out of the puzzles. My favorite. My favorite kind of marshmallow, Sarge. So what else we got inside here? I don't know if I really wanted this. Oh, capacitors. We're talking about chip circuitries, programs that say this is a, what is it called? It's not mega, mini, microhertz or microfarad, something like that inside of there, and their amplitude. So it'll charge for a little long, and then you actually put it on the battery. It'll be this long. I know the battery doesn't think it's like a sensible observation. The math, great. You can form it into all kinds of math problems. Say I got a 25 and I got to put them all together because I got a drawer in the inventory of the stuff I need, because the reality of the world is a railgun. My battery's only going to stay this so long right now. Alright, moving right along. Oh, of course I watched this. I was watching this one last night from yesterday. It's like it come out, and it's the new standard model about how we do that math. Otherwise, I have to defend against that Keter at the area. So either I understand it and integrates in terms of its being a capacitor, getting ready to fry out inside here because somebody's sending that thing down the pipes. Electron surge. I'm going to get you into deplating gold, strip tier here. This whole operation is electron. It's got free radiance everywhere waiting to zap you. Gauss curve. Stick your finger in acid. The whole building floor, hydromonium factory, dude. Well, it is. In the way that it's a stick in a field outside, right? You know, you just pick and rock with a dozer and that thing's chud with its teeth right at your knees, and you gotta get rock, throw it in there, makes it happy, it goes over there. You can cut down some trees for a little while, smoke a cigarette. You can't do nothing until it comes back other than cut trees. And as long as that's inside there, you're asking me to be Oppenheimer, multiform, Hannah Buddha, Valentine Rabbit, you will become it. Alright, so keep rolling. Alright, part G, I wanted him for optics because we were going to get into fiber optics here at some point in time. Composition elements, what will it allow, what will Omega, my death, kill agent in the room, allow me to get away with here for what we observe it and call it. Factorize where the geodesics of that points are going to be. And here in optics is what he's going with the, what was it exactly? A real image here is because this really isn't real, because we'll be arguing about subtle, very different things, and the thing is right in front of us. But if there is tiny optic differentials in the distance that thing's going on a stock account here, this horse, that horse, this piece of equipment, that piece of equipment, in a matrix of options and costs for rentals, operations, ones and zeros, whether you're on the hotline, it's hot or cold or up or down. Standard model spin's going to be the element, its weight, its decay form. Those optics are enough to neutrino that thing into a totally different universe of realities and things that come up. And here I want to check him out just because this is his new one from today. From
video. Check out a free trial of Skillshare Premium by clicking the first link in the
Bose-Einstein condensate is this room. Any kind of, when you say, well, what is condensation? It's an effect only when, prime numbers, only when the environment density difference, and therefore a condensate, would be with Einstein talking about states of matter and all the other elements in the room by name of their proper composition. You'll actually get inside of Fermilab over there. An EM field is a brain scan technology that what do you call them, an MRI, is actually what the heavy particle is in unstable breadboard form wires all over the place before they cut it into some chip. Here, Bose-Einstein quantum basics, just that's the foundation and special hot general relativity, cosmic radiation background. What do you do with it? For them, they might know what to do with it in terms of steps in programming that allow it to go full Flappy Birds in terms of the sample of what it does, but that in itself still becomes a standard model. That allows us to increase our productivity in creating God particles as students, but actual collisions of elements that are very tiny and small on timelines that are very far off, that are quantifiable by saying 1 and 0 is this environment can now be Bose-Einstein condensate. I can say Amphenol, Bluestone Mill, a field in the backyard with a dozer is Stanford. And to the levels of who you put in there, why, you get derivatives on dark matter, dark lensing, the devil, philosophy. All kinds of fun stuff pop out of there. Puzzles. What else we got? So chip shortage.
We're
from yesterday, day before, about a week ago.
In semi-production from the likes of Intel, Taiwan Semi, Samsung. So we will see this multi-year ramp up, but supply and demand here always tricky. Do we risk a supply glut in the future?
Try it.
Definitely. So these shortages seem to happen, about every 3 or 4 years.
There's a multiple answer. I'm not saying cellophane and that's not the right answer, but there would be. I have checked that standard model. Our technology is not up to date, nor is our momentum, kinetic, spin, mass charge moving in that direction for it to work in this universe.
What's hurting it, or what's making it worse
DC
now is
on
COVID,
an
right?
AC.
So if you look at any sort of assembly line out there, you're running at 25 or 50% capacity. So eventually it'll get solved.
Raspberry 5 has been pretty good. That MOS.
The
2506.
We're probably seeing
and
that
got that
already.
Z-Coin, that Z-chip, which is basically the same thing as the MOS. And then there's little switches that build in circuitry to that complexity that piggyback off of that, allows it more room, more build-in. You get something like Amphenol as a chip, and that's why it's a superconductor, or a supercomputer. It is a superconductor in the fact that it's just the spot that produces something YBCO, faster magnetic flux pins in terms of what that situation is. And, so you can kind of 1s and 0 way you through that matrix there, pop out old Agent Smith whenever you want, because you never know if you are or not. You might be. Alright. You be quiet, burn rock, do stuff, put it in, take it out, put it in, take it out, push a few buttons, hone it up, put it back.